So, here's a cool trick with gradients. This doesn't seem like it probably involves gradients, but
Is
whatever.
that point even on
So, I want to find an equation of a tangent line to f of x and y is 4 minus x squared minus 2y squared at 1, negative 1, 1. And the first question you should ask is
that even on the plane?
Is that even on there, right? Like, is this point on that surface?
It looks like it is.
How do you check?
Plug them in.
Plug them in. So is 4 minus 1 minus 2
Yeah.
check?
Yeah.
Cool. If it wasn't on there, what would I do?
Change the number.
Yeah, adjust the z value or say,
Hey Joe, you got it.
nope, not going to happen. Cool? All right, so now what am I looking for to get the equation of a tangent line? Tangent line. Tangent plane. Tangent line doesn't make any sense, right? There's not one, there's lots. In fact, so many they make a plane. So how do I find the equation of a tangent plane?
X slope, Y slope.
I could find that x slope and the y slope, right?
Then plug it in.
And then I could plug it into that equation. Alternatively, I could use my new toy.
The cool trick.
Yeah, so the gradient vector is perpendicular to the level surface, right? This thing is not a level surface a priori, right? You guys see that?
Yeah.
So let me make it a level surface. Let me just look at this thing and think about this as taking some other f of x, y, and z and setting it equal to 0. You guys see that? No?
So are you going to do a quadrat? No.
All right, so how could I make this the 0 level curve of some...
Oh, okay, never mind. You added a variable stuff.
See that?
Put a negative z in there.
Yeah. Okay, so I could think about this as the level curve of z equals 4 minus x squared minus 2y squared, right? Yeah, and then I could move the z over. So I could do 0 is 4 minus x squared minus 2y squared minus z. Oops. Okay, and then this could be my f of x, y, and z. Okay. So, what's the gradient of your capital F function now?
Let's see.
0.
Fx of y of c.
Okay, so what's fx?
Fx is
Negative
2x.
Negative 2x.
Negative 2x.
Fy is
Negative 4y.
negative 4y. And fz is
Negative 1.
negative 1. Okay, so what do I know about the gradient vector?
Perpendicular to that.
It's perpendicular to the level surface, right?
So, now we
So
have a
this
vector
gradient
and a point.
vector is perpendicular to this surface f, right?
Plug in the point.
Vector and a point.
Yeah, I've got a
On the
perpendicular
plane.
vector, right? That's that normal vector. You guys see that? So I'm really looking at this thing and I'm thinking about normal vector. And this is where you get them, right? Remember we had that equation that didn't seem super useful? That we can dot a normal vector with a displacement vector, set it equal to 0, and get the equation of a plane. And it seemed like there was no place to get a normal vector, right? But here's a way to get one. Cool. So if I want n at that point, what's my...
So plug it in and divide by the length of it.
Do I need to divide by the length?
Well, you said you wanted just any vector could be the normal.
Yeah, any vector that's normal. It doesn't need to be a unit vector because I'm going to dot product it with the displacement vector and get 0. Right, so I'm really thinking about this. I'm thinking n dotted with displacement is 0. So I need to conjure up an n and a displacement vector. I think this is a good candidate, but this has x's and y's in it, right?
So we'll plug it in.
So you plug in a point.
So I need to plug in my point. So that vector should be what?
Negative 2, 4, negative 1.
-2, 4, -1. Okay, awesome. And I'm supposed to dot this with, what's your displacement vector going to be? You guys remember how to make that one?
X minus
X minus 1, y
some
plus,
other
X
point.
minus 1, y
plus 1,
plus 1,
z
and
plus
z minus 1 equals 0. And so if I multiply this out, right,
Yeah, and -2 plus 2
I get negative 2x plus 2
yeah, and then 4y plus 4
plus 4y plus 4
minus z plus 1.
minus z plus 1 is 0, and then you could consolidate like terms here. Okay, so in the end I got negative 2x plus 4y
Minus z
minus z
plus 7.
plus 7 is 0. Damn, plain. Cool.
Can I see a picture of the normal vector against the surface?
Sure.
Just generally.
Yeah. In fact, for this one, it's relatively doable to draw. So, what's this shape? My level surface here? F?
Downward ellipsoid.
Yeah, it's a downward elliptic paraboloid. So,
Perfect. Elliptical.
okay, so here's your kind of downward elliptic paraboloid. And we could label some points on this thing, like the z-axis hits up here at
4. 0, 0, 4. Or
4 high, so 0, 0, 4, right? And then the x-axis hits here at
negative 1.
This one, is it
Oh, no.
1?
Oh. Z0, Y0. So, 2.
Yeah, it would be like positive 2. Yeah, plus and minus. Plus and minus 2. Because it's on both sides. Be positive. Yeah, that one would be positive.
Radius is always
positive 2, right? I'm asking when's the output 0, so that's 0 over here, and the y value is also 0. Right, so that's asking when is 4 minus x squared 0? Well, positive 2, which really is 2, 0, 0, right? And then back here, where's my y-axis hit?
Root 2.
Yeah, root 2.
Root 2.
Root 2. Oops. What's the point?
0,
0,
so root 2.
0, root 2, 0. Good. Cool. Alright, and then where's the normal vector? So let's see, I'm supposed to be looking at the point 1, negative 1, 1, right? Oh, so that's on the back side of my bowl, right?
Oh, it'd be the front. Looking
Yeah,
this
it'd be
way.
the front.
Ah, thank you. Yes, front. Good. So I'm supposed to go 1 over and 1 forward, which is not quite all the way out, right? And then I'm up 1. So I've got some dot here. Oops. That be not to scale drawing is fine. Okay. And then that normal vector
-2, 4, -1.
is perpendicular to that. And in fact, we found it was negative 2, 4, 1, right? So that's pointing, yeah, 2 left,
Back.
4 in, down 1 is into the surface. So I've got this bowl, and this thing's jamming through it.
Why does it point inward and not out?
I don't know. Good question.
You're
It's
talking
in
about
terms
the
of
y-axis?
greatest increase, right? For the function. Right, remember the function we made was f of x, y, and z is 4 minus x squared minus 2y squared minus z, right?
Okay, so we're looking at a three-dimensional slice of something that's four-dimensional.
Yeah.
Okay.
And that's why it's pointing in a kind of weird direction, right? if I took the gradient of my little function f, right, that gradient is going to
I
point
kept thinking it was pointing
this way, right? That's going to point
perpendicular
uphill on
to
the
the
surface.
level surfaces is what I was thinking, but that makes a lot more sense.
You guys see that? So there's two pictures happening here, right? There's the capital F picture, which is I took a 3D slice of a 4D object. And then there's the little f picture, right, which is a two-dimensional function, right? So that's this 3D object. These are the same things, but the gradients of them mean slightly different things. The gradient of the little f is on the bowl, right? That's a vector pointing uphill on the bowl.
If the gradient or if the slope is steeper going down, will it overwrite the gradient?
No, the gradient always points uphill.
Always point back.
Yep. And the steepness will be the same because it's a tangent line, right?
Yeah.
Cool? Questions, things? If the steepnesses are different, you have a point of non-differentiability, right?
Mm-hmm.